Today we are talking about these, the new Fatshark Dominator digital FPV goggles that are compatible with the Avatar HD system, and in this video we are going to be tearing them down. Today I'm going to walk you through what these goggles are like internally. We're going to take a look at the PCBs. I'm going to give you then some thoughts at the end on what I think the build quality on the hardware side of things on these goggles is like. Now, just before I jump into that, I just want to say a massive thank you to all of my Patreons. I would not have been able to make this video and buy these goggles without their support. If you are interested in seeing more content like this in the future, please do make sure you are a subscriber of the channel. If you do find this video interesting, please do give us a like, and if you want to support us to be able to keep making independent content like this, please do check out the links to my Patreon as well as Buy Me a Coffee. It is only through the support you give am I able to keep buying the products and then hopefully bring you some interesting and unique content. So let's get on with it and start taking them apart. Okay, so what we're going to have to do first of all is remove this mask that goes around here. To do this, the best thing to do is just grab it in the middle, give it a bit of a gentle pull around the eyepieces towards the edges there, and you will feel that it will actually pop free, and then that reveals this area of the goggles here. Once the faceplate is removed, you need to take out these 4 screws. We've got one here, 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 and here. And once you do that, this front white bit will actually withdraw forward. These are not Phillips, they are actually Torque screws, so you do need to be aware of that. And you're going to need one with quite a long, thin drive end on it as well to be able to get down into the areas where the screws go in. So I've taken out those 4 screws and the front panel is loose. Now this will simply withdraw forward from the goggle like that. So you want to gently push it out. The first thing you'll find is that there is a fan on the front here, and then you do have your antenna connectors that go from the front onto the main PCB, which is located here along the top. If I just flip it up to show you a bit better, you can see that we've got 2 boards. We've got a board down here and we've got a board along here. We have our 4 antennas, 2 from the front and 2 from the top ports, which we'll talk about a little bit more in a minute. And then we've got the ribbon cables for our OLED displays, and there's a couple of other cables located underneath down there as well. Now, something to note is there is a micro USB port on the front of this board, which is only accessible from the inside. We'll have to take a closer look at that in a minute when we get in. There's also a couple of other ports here as well. Now, the next thing we need to do is disconnect the antennas to make sure that we get them out the way. You will need to note what order they're actually in. Now, I've checked this already, and from my tests, the best way to look at this from the main PCB is that from the antennas pointing this way, that is number 1, that is number 2, that front right is number 3, front left is number 4. So 1, 2, 3, and 4. Now, these are UFLs. You can see them if I just pull the board forward a little bit. You can see the UFL connectors under there, so you've got to be very careful to take them off. It's also worth noting that there is this cable on the side here as well. You're going to need to disconnect that too to get the board out. So the next thing I'm going to do is get these off. Next, it's time to remove these 2 ribbon cables for the main displays. Now you can see that they loop over here and go down to the back of our OLEDs, and these simply unclip from the main PCB here. You want to very carefully give them a tug, and then you can see that the connector will pop off. To make your life a little bit easier on this, you can withdraw the board forward slightly, giving you more access to this area. There are 2 other cables you need to be aware of. There is the black power cable you can see at the top right that goes from the little PCB to the main PCB. This simply unplugs nice and easily. And then you've got this ribbon cable that mounts to the bottom of the board. The connector is under a small piece of tape, and the cable itself, the ribbon, is actually stuck to the PCB with some double-sided tape. So you need to very gently lift this off before removing the board. Once that tape's removed, you can see we just have the little connection here, so we simply then need to just pop it off the board nice and carefully. Once all the connectors are removed off the board, it actually just gently slides out the front of the goggles on a little rail. You can gently slide it out and remove the board just like that. Just looking inside the goggles now, I've got the board out the way. You can see obviously our OLED displays with the mechanism down here for the IPD adjustment. So just to show that, you can see that that moves, as well as our focus adjustment. We have our two very delicate ribbon cables, and then we have our power input board, our DC board, located over here. Now, I'm not going to get this out a minute. It actually appears to be sandwiched between the case on the goggles. It doesn't look like it's easily removable. It's got the buttons on the top and bottom as well for controlling the goggles. I would have liked to have got that out, to have had a closer look to try and see what the difference is between this and maybe the Walksnail goggles, but I'm not going to do it at this time. It's wedged in there and I don't want to tear them down to that point quite yet. Then finally over here on this side we have another fan. It appears actually to be dragging air in or out through this area here on the goggles. That actually is more than just a logo. There's actually gaps all the way around it, and I can see that the fan seems to go through there. So again, that might be part of the fogging mechanism. We do have that fan on the front display here that you can see as well, but there is that one there too. Now you can also see our connections for our RP SMA ports. We've got the two at the back there, and then again, if we look at the front cover, we have our two on the front, with the fan located in the middle. Fairly easy to access actually if you wanted to change them, but again, you would have to remove the cover to be able to do that. So the main PCB is out. Now this is the side with the antenna ports along the bottom. We have antenna 2, 1, 4 and 3. We have our display interface. We have our UART up here. It appears to be TX0 and RX0. We have that connector that goes to the other side, and you can see that there's this plastic cover over the top of what looks to be a shielding can with our SD card input down there. Now this plastic cover does appear to have some holes and gaps, so it's directing airflow on the cooling. You can see that there's something there, and then there's something there as well for getting it out. If we flip over to the other side of the PCB on here, you can see that we have two ICs down here. These are Toshiba display interface ICs. We have a flash chip, we have a battery, we have our buzzer, we have another connector over here, and then we have that micro USB OTG port. We have what appears to be another UART, which is TX5 and RX5, as well as an I2C port potentially there as well. So next, we need to jump in and take a look at what we find under the can. For the remainder of this video, we're going to be looking at still images of the boards that have been taken and walking through what we've actually found, rather than do this bit as a video as such, because this allows us to dive in deeper. So here you can see the main board taken out of the unit. We have our UFL connectors along the top here for our antennas. We have our connections for our displays. We have a wire down here which goes to our power board, so that's the main power input for the device. And you'll also note on this side there's actually a UART by the looks of it, which is ground, TX0, RX0. Now there is this plastic cover, as we showed earlier, over the top of the board. When that plastic cover is removed, it reveals this can underneath, where we can see it's pressed in certain areas where there are chipsets located beneath. If we dive across, once the can is removed, now you can see the main PCB itself. Now here in the middle here, we have the main SoC. There has been a huge amount of talk on this, and I'll come back to that in a moment, but you can clearly see it there on the board. Here we have our RF transceivers, which are the IE2000s. We'll take a look at them a little bit more in a moment. We have our flash chips over here, our SD card, as well as an additional chipset down here. You can now see, looking around the board as well, there are various other components. We've got our sundry components located over here. We've got a power regulation area here with this other IC. So you can see we've got our coils, we've got an IC. There's some unpopulated diode areas here as well. Looks to be another IC down there. All of this very basic circuitry. If we dive in and just take a closer look at the RF area, this is actually quite interesting because we have 4 antenna ports labelled 1, 2, 3 and 4, which are in pairs to each of the transceivers. But you can see there are little ICs here, which there are 3 of, and then you have the larger IC here. Now, what we have on this is a setup that appears to be that there are 3 RF ports that receive, but only one of them transmits, because this IC here is the main power amplifier IC. That is the same style and design of IC that we see in the Vista. It's an IC from Skyworks, and that is the main PA, and that is hooked up to the antenna 1 port only. On antenna 2, 3 and 4, there are these little ICs, which are the SKYs 15605s. After investigating these, they basically appear to be receiver, preamplifier and switches, so they are not transmission amplifiers. That means the setup of these goggles, and this aligns with all of the testing I've done, is that antenna 1 will be the only antenna that actually transmits RF, and antenna 2, 3 and 4 will be the reception antennas. Now, as you're looking at this from above on the goggles, that will mean the top right-hand RPSMA port, as they're on your face, is the transmission one. The top left and the front 2 ports will be reception only. Here you can see, again, we've dived in a little bit closer with the paste now removed, and you can see the transceivers, which are the IE2000s. Again, with our power amp located down here, only going to that RF1 output. Obviously, there is some things to discuss on the chipset. Now, the SoC is labelled a Xilinx Vertex XC5VL-X50T. I have put a separate video out on that. Now, as I've said in that other video, all of the information we have is that this is not a Xilinx FPGA, regardless of what the label on the top says. It is etched, however, that doesn't mean that is what is below. There are so many elements of this that say that it is not that chipset. For starters, it doesn't align up with the pin 1 location. All Xilinx FPGAs have the pin 1 in the top left compared to the logo. There is no Xilinx package of this that matches that. That model number does not make sense, and in fact the FPGA that would contain that model number does not have what is needed to be able to do what is being done in these goggles. As I've shown in the main image of the board, there are no other ARM-based SoCs on here. There is nothing to run the operating system other than this chipset labeled as an FPGA. However, this model is not capable of running ARM soft cores. It does not have the PowerPC cores built in, and it does not have everything that is needed to be able to actually run that system that it is being asked to do. There are chipsets that do match this, which are the 2 from Artisan, which is the AR902 as well as the AR8211. At the moment, all of the information we have is pointing to it being one of those 2 chipsets, most likely the AR9201. However, it isn't 100% confirmed at this moment in time, but what we are dealing with is the code is telling us that it's an Artisan chipset, the package is telling us it's an Artisan chipset from the look and feel, and it does not align up in any shape or form to being a Xilinx FPGA. Moving around the rest of the board here, you can see our flash chips. We have them just below the main SoC. Flipping around to the back of the board, we have a couple of other ICs, which is our 2 Toshiba IC interfaces for our OLED displays. These are the 358778XBGs, and there's one of these for each display. You can see we've got the battery on the back of the board, we've got the buzzer, which we showed earlier, and then we've got that WinBond flash chip down here too, with that USB port up here. The UART TX5 and RX5 on this little port here, as well as what appears to be I2C located over there. Now, as I mentioned when I tore the goggles down, there is one other board, which is this one, which appears to be the basic input board for the goggles. On the one side, we appear to have just power regulation. So we have our DC input jack, we have 2 coils, so we have a buck converter down here. You can see we've got our USB-C port over this side here. You've then got the connector and this ribbon cable that goes off. If we flip over to the other side of the board, you can see that this ribbon, the one that you've got to be a little bit careful with, goes directly to the USB-C. We've got basically a fuse on the back of the board here. You've got your switches and a couple of diodes, but really this is simply power. There's no processing or anything else going on this little one. Okay, so to give you some thoughts, the overall build quality on these goggles is actually very, very good. The hardware externally is decent. I've got no complaints at all. The fit and finish is good, and I will touch on that a bit more in my review video, although I will say mine came in dirty, but again, we'll talk about that later. Internally, I actually have to say they are very well designed. Access to everything is fairly straightforward, apart from that board on the side. We'll come back to that in a second. Gaining access to the goggles is just those 4 screws, and then the front. Okay, so to just share with you some thoughts on the goggles hardware. Now, overall, I have to say the fit and finish externally is very, very good. They are lighter than I thought they would be, but the quality of the plastics feels good, and there is zero complaints out there. What's out there? Okay, so to share with you some thoughts on the hardware. Now, I'm not going to spend too much time externally because, frankly, they're very good, and we'll talk about that more in my review, although I will say mine did come in a bit dirty, but again, we'll touch on that in the next video. As for the internal design on these goggles, I have to say it is very, very good. The disassembly is fairly easy to gain access to the front. It's just those 4 screws. Once they're out, you get easy access to the UFL connectors for the antennas, and there's actually quite a bit of space in there. In fact, you could have probably crammed in enough room for another board and even a module bay on the front of this if they had really wanted to. That main PCB appears to be very well designed. The quality looks good, the soldering looks good. There is zero complaints there at all. The only thing I will say is gaining access to that power board on the side is quite difficult. I didn't remove it on mine, though someone else did, as I showed in the images. And to do that, they actually had to take the back end of the goggles off, which then allowed them to withdraw the board. It is a little bit annoying because that is the most likely board you're going to need access to should you accidentally do some damage to the power input. However, you would need to do a bit more work to get it apart, and I'll probably touch on that in a later video. I'm not going to tear them down to that level today. Overall, I have to say, from a design point of view, it is very, very good. No complaints on the hardware design at all. You can clearly see that there's been some input on people who know what they're doing, that is for sure. Anyway, that's it from me on this one. I hope you have found it interesting. As I said at the start, if you'd like to support us to allow us to keep making content like this, please do check out the links to my Patreon as well as buy me a coffee. If you have found this video interesting, please do let me know in the comment section. Please do give it a like. If you have any questions, put it in there. I'll try and answer them as well. Anyway, that's it from me. Stay safe. I'll speak to you soon.